Hi astronomers, Caroline here. In our last lesson we explored Mercury and Venus. And although they are both super cool planets, neither seem to be the best fit to answer our question, which planet offers the best conditions for a successful crewed mission? But we have one more terrestrial planet to consider. Today we are going to focus on the fourth planet from the Sun, Mars. By the end of this lesson, you'll be able to compare and contrast key characteristics of Mars with Earth and explain why Mars is different from Earth and the other terrestrial planets. Let's get started. Remember that the four planets closest to the Sun are terrestrial planets. Terrestrial planets are smaller in size and have hard and rocky surfaces that we could land on. Mars, our planetary neighbor, is farther from the Sun and is half the size of Earth. Mars is sometimes visible from the Earth and appears as a bright pink-red spot in the night sky. Mars's red color comes from rock dust that is in the air. Although it is dusty and mostly made of carbon dioxide, the atmosphere of Mars is very thin. We decided that the extreme temperatures caused by the atmosphere on Mercury and Venus would prove very difficult for a crewed mission to manage. What do you think the temperature of Mars will be like? Will it be similar to Earth's temperature, or maybe like one of the other terrestrial planets? Go ahead and pause the video and make a prediction in your notes. Earth's thin atmosphere is just right for regulating our global temperature, but Mars's atmosphere is much thinner. This results in temperature swings on Mars that are similar to those on Mercury, with a large difference between day and night temperatures. Nights can drop to negative 255 degrees Fahrenheit when Mars is facing away from the Sun. Days, however, can be more Earth-like. When Mars is facing the Sun, temperatures can reach 70 degrees Fahrenheit. Since Mars is not as close to the Sun as Mercury, the temperature variation may be a bit more manageable for a crewed mission. A day on Mars is just minutes longer than a day on Earth. So a crewed mission would still need to be able to deal with the extremely cold temperatures for 12 hours every day. In addition, they would need to keep track of the seasons, since the axis of Mars is tilted like Earth's. It takes about 2 Earth years for Mars to make one revolution around the Sun. The length of the seasons varies because of its elliptical orbit. That means that the winter on Mars could be more than twice as long as here on Earth. Although Mars is cooler than Earth, it seems like the temperatures on Mars might work for a crewed mission. However, to stay there for any length of time, they would need the essentials for sustaining life: energy, nutrients, and liquid water. Mars has energy and nutrients, but right now, only Earth has liquid water. Why do you think the Earth can maintain water in its liquid state? Our atmosphere is able to keep temperatures in the range for liquid water. What other states of water do we find on Earth? Frozen water and water vapor, which also depend on temperature. Earth's orbit falls right in the middle of the habitable zone. The habitable zone is the distance from a star where temperatures are just right to maintain liquid water. Even though Venus falls in the habitable zone, we've already seen evidence that it has a thick atmosphere and extreme heat, which would cause water to evaporate. What do the colder temperatures on Mars mean for water? The water is currently frozen underground. However, evidence suggests that in the past, Mars was warmer because of a thicker atmosphere and therefore had liquid water. Today, with high temperatures on Mars reaching the 70s during the day, a crewed mission would only need to find a way to keep water liquid at night and in the winter. be wondering, how do we know all this about Mars? All this evidence was, and still is, being collected. There have been 40-plus missions, including robotic orbiters, landers, and rovers that have visited Mars. In addition to collecting data about the atmosphere and temperatures, they've also explored the surface of Mars. Mars's surface features include volcanoes, impact craters, canyons, dust storms, and regolith, or Martian soil. When scientists tested the rock and regolith samples from above the hard volcanic rock, they detected iron, magnesium, and other nutrients. The red, brown, and tans of the surface are from the iron in the rocks rusting. Speaking of Mars's surface, we have one last factor to consider before sending a crewed mission to Mars: the gravity. Based on your knowledge about gravity on Mercury, Venus, Earth, and the Moon, what will gravity be like on Mars? Pause your video and record your prediction. Mars is about half the size of Earth, so you may have predicted the gravity should be about 50% of the gravity on Earth. If so, you are on the right track, but we also need to consider that Mars has much less mass than Earth. This reduces the gravity even further. The gravity on Mars is 38% of the gravity on Earth. This is between the gravity of Earth and the Moon, so we know a crewed mission will work. Now that we've explored different aspects of Mars, let's recap our discoveries about this fascinating planet. You now know that Mars, like Earth, is a terrestrial planet within the habitable zone. It's about half the size of Earth, and its red, rocky surface has volcanoes, craters, and canyons. Since it has a very thin atmosphere, Mars has big temperature swings. The cold is more extreme because of its distance from the sun. Mars currently holds the most promise for a future crewed mission, and it's looking inevitable that it will happen sometime in the future. As scientists make more observations and collect more data with orbiters, landers, and rovers, they will be better able to plan how a crew could navigate the terrain, access water, and withstand temperatures on Mars. The hands-on engineering design activity for this lesson gives you an opportunity to explore how we might regulate or control water temperatures on Mars. In our next lessons, we'll keep exploring the other planets. And always remember, you are out of this world. See you next time.